Dear students, welcome to Knowledge Hub. I am Dr.NH. In this session, I am going to teach you basic concepts of chemistry, class 11. Hope this will be useful for the students appearing for CBSE, JEE, NEET, etc. I wish you get good marks by following my teaching, and if you have any doubts anytime, you can send your comments below my videos and I will be happy to reply to your doubts or questions if any. In this session, as I told you, we will discuss about basic concepts of chemistry. Now the people will have doubt, what is this chemistry? Students, you may have these questions, and different teachers and different level of our classes, teachers are giving different definitions, books we find different definitions, etc. It's true, because chemistry is a science which deals with huge number of elements and compounds. You see in periodic table, then it is classified 108 elements there. But new inventions are also coming. But these are not limited to that 108 elements what they have been classified. And it took lot of research and application of mind to classify the elements in the world, and our forefathers, scientists, have given us a very easy way of classifying this chemical based on their properties, and today we are very comfortable in studying about them. Now, from my understanding, I can say that chemistry is a science, branch of science. It deals with elements and compounds and the reactions between them. So the reactions means it's not just reactions, but that reactions leads to invention of more compounds. On the top of the list we have carbon and hydrogen. This carbon and hydrogen form infinite number of compounds which we know already. For example, we have benzene, aliphatic compounds like methane, ethane, and we have petrol, diesel, and so on and so forth. And the other chemicals, like in daily use at home, we use floor cleaners and soap, detergents, etc. In cooking also we use sodium, salt, table salt, sodium chloride, and cooking soda, the baking soda, etc. And if you see the medical field, we have a lot of medicines. They are not just from other science. It is from purely chemistry. They are all manufactured by synthesis of various compounds. After studying them and their results, the scientists, study their results on the human being. They do the clinical test, then they formulate the medicines. Now we are comfortable that we have many stores, medical stores or chemist shops, where we can easily go and say that I have this problem, I have that problem, or we can go to a doctor and doctor able to prescribe medicine because of this hard work of chemists. It is now has taken a different branch of chemistry. We say that pharmacology. So lot of benefits. Say we have got common this one, paracetamol, ibuprofen, which we know, Imol. Okay, these are all we know. And if you see the book, they have named a few cancers. Medicine for the cancer or AIDS, which you can refer to the book and understand. Also, we know a lot of chemicals like pesticides, herbicides, uh, and fertilizers, all those things. And naturally also we know chlorophyll. Chlorophyll is also a compound. It's a coordination compound. In the blood we have red blood corpuscles. They are complex of iron and protein. So hemoglobin. So globin. This is a hem means iron. Globin is a protein. So like this we have lot of things around us which chemistry has given to us. Now let us discuss about matter. The matter is the one. What is matter? Is anything which has got occupies a space and which has a mass. Anything which occupies a space and has a mass. For example, this pen, anything you take, this duster, so it has got a mass and it occupies a space. The matter is classified as solid, liquid and gas, and solid has got definite space and volume. So the particles, or it can be atom or molecule, they are closely packed. For example, sodium chloride is an ionic compound. This is closely packed. Okay, these are the different atoms or ions. In sodium chloride, one is sodium, another is chlorine. They are closely packed. So they have got a definite volume and they have got definite shape. And liquid doesn't have a shape, and it is got only volume. So it will take the shape of the container where we will put the liquid. And the particle here is, they are not close, they are compared to solid, they are far off. Okay, so they can freely move. Then coming to the gas, they are totally free and the molecules are not close and they don't have shape of their own, they don't have their volume of their own. Now the solid can be transformed to liquid and the liquid can be transformed to gas by way of heating. The symbol solid to liquid, liquid to gas by heating. And again it can be, gas can be cooled to liquid and the liquid can be cooled to solid. Example, you have ice, water, steam. So the reverse process happens upon cooling. The forward process happens upon heating. So this is about matter, and we can see in a macro level about the matter. Dear students, we have already discussed about the matter. Now in macro level, the matter is classified as mixtures and pure compounds. Mixtures, you can say sugar, air, water, tea. Means sugar, if you put in water, that will form a mixture. Air is already a mixture. Water is already a mixture. It contains a lot of salts in it. Tea, of course, you add milk, tea, etc. Now coming to mixtures, this has been classified as again homogeneous and heterogeneous. Homogeneous means uniform. You know, they distribute. If you put a solute sugar and in water, it will be distributed uniformly. So you don't find any two separate layers in that. So similarly, air is also, you cannot see visibly, but it is a mixture of oxygen, nitrogen, hydrogen, etc. So this is homogeneous matter. Example is sugar solution, air, etc. So they have uniform composition. Now the same thing, you come to heterogeneous mixture. Okay, under mixture. The heterogeneous is salt and sugar. If you mix salt and sugar, they don't mix. Similarly, pulses and dust, and they have no uniform composition. And for example, if you put another example, like if you put sand in water, and then they will be in two separate layers, they don't mix. So they are not uniform in composition. Now going to matter other division. I can say classification. So one is mixture, other is pure compounds. In pure compounds, they are further classified as elements and compounds. Elements you see like copper, silver, gold, hydrogen, carbon. These are all called elements. The compounds, I think more than one element combined to form compounds. So, like for example, two hydrogen combined to form H2, and two hydrogen and one oxygen combined to form water, and three hydrogens and one nitrogen combined to form ammonia, and two oxygen and one carbon combined to form carbon dioxide. So, again, pure compounds has been classified as elements and compounds. And yeah, then we can discuss further on this subject. Hope you understood the matter. Now we will discuss about the properties. Matter has got physical properties and it has got chemical properties. Physical properties, for example, color, boiling point, melting point, odor, density, etc. So, color, boiling point, melting point, odor, density, etc. Now, regarding chemical, we know acidity, basicity, etc. Now, we will discuss about the SI units. See, here I have given you the SI unit, which is International System of Units. This is basically from France we are following. Okay. Now, we should know the important physical quantities. Like to measure length, we have a symbol of L, and name of the unit is meter. We measure in meter, centimeter. You know it. Then the symbol is M. Then we have a mass which is having a symbol of M, small m, and we measure mass in kilogram, not in pounds, okay, in kilogram, and in the symbol is kg. The time the symbol is T, and we know that hour, minute, second. So second is S. Okay, the unit symbol of SI unit is S. Electric current I, the name of the unit is ampere. We measure the current in amperes. The symbol of this unit is A. Then we have got a temperature measurement. See, usually we measure in degrees centigrade, but we have got from SI unit, we have got the temperature measurement as Kelvin. The symbol is K. You will learn what is K a little bit later. Amount of substance we measure, the symbol is N. We measure in moles. The symbol of the SI unit is MOL. So you just remember these things. We will come across these units very often, and we will deal only with this SI unit while measuring length, mass, time, electric current, thermodynamic temperature, amount of substance, etc. So this will come frequently in your calculations and other things. Dear student, please note down this table, which gives the prefixes usually in SI system, column multiple, then what is the prefix for that, then what is the symbol for that. 10 power minus 9, 10 power minus 9 nano, 10 power minus 6 micro, 10 power minus 3 milli, 10 power minus 2 centi, 10 deca, 10 power 2 hectare, 10 power 3 kilo, 10 power 6 mega, 10 power 9 giga. Then you have got symbol N, nu, M, C, D, A, H, corresponding K, M, G. Please note down this. This you will come across in due course. Dear students, now we have to learn the units of volume, density and temperature. Most of you already know it, but since we are going to deal with the volume, density and temperature in the future, it is just like refreshment. We can refresh your memory. So now volume, it is expressed as centimeter cube or dm cube. 1 liter is equal to 1000 ml. Everybody knows it. 1000 cubic centimeter is equal to 1 dm cube. Okay. Then we have got density equal to kg per cubic meter or kg per cubic meter. You written this way also. So it is a large quantity. Since we are dealing with atoms and molecules which are very small, so we deal with the gram per centimeter cube. This is often used. Then we have got temperature. You know, degree centigrade normally used as a SI unit. Then this is American, Fahrenheit. The conversion factor is 9/5 degree centigrade, whatever it may be, plus you 32 add, you get a Fahrenheit, value of the Fahrenheit. Then Kelvin, I told the Kelvin SI unit. You add 273.15 to the degree centigrade at STP, standard temperature and pressure. So these are the things basically you should understand. So that's why I am giving. This will be useful in your future calculations also. Next, we will discuss about uncertainty measurement. So, since we are dealing with molecules, atoms, electrons, etc., so their number may be huge and their weight may be very, very, very small. So, for example, if the number is this, like this, and if the weight is like this, it's a very small. So, how we can represent them in a simple way? So, for that, we have a format. Like n into 10 power n. So n is an integer or digit. N is a digit between 1 and 9.99, and n is an exponent. N is an exponent which has a positive and negative values. So now, for example, if you take 232.508, that we can represent as 2.32508 10 power 2. Here we have shifted the point here on the left side 1 2. So to make it simple, to look like a simple number, and so like this. So here this is positive, 10 power 2 is a positive. Now we take a small number 0.00016, and that we can represent as 1.6 in 10 power minus 4. Shift that point to right, 1, 2, 3, 4. So 1.6 into 10 power minus 4. This is how we can make the thing simple to represent the values of very huge numbers and very small weight of these molecules, atoms, electrons, etc. So that is how we do. See, under uncertainty measurement, now we will discuss about multiplication and divisions. In multiplications, you multiply the number n into 10 power x into n dash 10 power y. So in this case, you have to add x plus y. So like this, n into n dash into 10 power x plus y. Now you have minus in the exponent, minus x here, the minus y here. So n into n dash, okay, into 10. You have to add this minus x plus minus y. So the result will be n dash 10 to the rise 10 to the power minus x plus y. So it will be like this in multiplication. In division, if you come, so you have n into 10 power minus 3 divided by n dash into 10 power 4. So you can write n dash divided by n dash. So 10 power minus 3 plus minus 4. So add this minus 3 minus 4 and it will be minus 7, then n dash into 10 power minus 7. So this is how we use the format for multiplication and division of huge numbers or very small weights in chemistry. Okay, well representing molecules, atoms, electrons, etc. So this will you have to follow these things. It will be very helpful in during the course of your study. Under significant figures, we will now discuss about the precision and accuracy. Assume that the three students A, B, C are doing one particular analysis and they are supposed to get the results. The results are expected to average 2 gram. Now A is analyzing and he is getting two results. In the first time he is getting 1.5, second time 1.93, the average is 9.4 and he is nowhere close to 2, but his results are precise but it is not accurate. So case of B, he gets 1.94, 2.05, 1.995. His results are neither precise nor accurate. And case of C, he gets 2.01, 1.99 and the average is 2. These results of first analysis and the second ones are very close to 2. So his results are precise and accurate. I hope you understand what is precision and accuracy. Rules of significant figures. Rule A. All non-zero digits are significant figures. Example 285. Here we have three significant figures. Here we have point and after the point we have 2. So this is two significant figures. Or this is a non-zero digit. So number 2, rule number 2. 0 before non-zero digit are not significant. See here, 0 before significant figure. Okay, 0 before non-zero digit. 0 before 3 is not a significant figure. So here the significant figure is only 1. So here you see 0.0052. Here only two significant figures. These 0 are not significant. So similarly you take rule number 3. 0 or zeros between two non-zero numbers are significant figures. Example 2.005. Here the significant figures are 4 because we are including these two zeros also. So 1, 2, 3, 4, 4 significant figures. The last rule, 0 at the end or right of a dot are significant figures. See for example here dot. After the non-zero digit, we have two zeros, but they are also significant figures. So here in this example 0.200, there are three significant figures. Now you put 100 dot. Okay, here significant figures are 3. Then here 100.0. The significant figures are 4. Then if you simply write 100, the significant figure is only 1. So these are the rules we should learn about the significant figures. Now let us learn about rules for addition, subtraction, multiplication and division. Now take the case of this addition. 12.11, 18, 1.012. The result is, total is 31.122. This is an addition. Now the result should correspond to the one which has got minimum digits. Here 18 has only 3 digits, which is the minimum. So the result, though we got 31.122, the result should be written as 31.1 only. Okay, this is the simplification rule regarding significant figures. Coming to multiplication and division, similarly same logic applies here. 2.5 into 1.25. The result is 3.125. But what is the smallest significant value having the smaller number of significant figures is 2.5. So the corresponding results, the results should be correspond to this. So though we have got 3.125, the result should be written as 3.1. So this is what the significant figure rules tells us about addition, subtraction, multiplication and division. Hope you understood this. See, let us talk about rounding of numbers. Now 1.386. Now I want to round off this number after decimal, two numbers after decimal. So how I can do? This 6 is more than 5. If it is more than 5, you increase the previous number by 1. So the result is 1.39. Okay. So I increased 8 to 9 here. Okay. Now the second. If the number is less than 5 here, as it is 4.33, for the 4 is less than 5. Now what you do? Just leave it. Don't increase or reduce this number. So the result is 4.33. Now the case of 3, 6.35. Now here the number is odd number. 3 is odd number. In such case, if you want to round off this one, since the next number is 5, okay, then increase by 1. So the result is 6.4. Suppose if this is all, if this number is even, like 6.25 and 6.252 is even, you have 5, you want to increase this one, and the rule says don't increase, leave it. Odd means increase by 1, even means don't increase. So the result of 6.25 is, after rounding off, is 6.2. Hope this is clear to you. Okay. Subsequently, I think I will finish this video part, and I will take the other mole, molarity, molality, Gauss laws all in the subsequent part 2 video of basic concepts of chemistry. Okay. Thank you for watching. Please subscribe my channel, share with your friends, give likes, and if you have any doubt, please ask me in your comments. I will try to reply to your queries in my subsequent videos on the same topic. Okay, thank you for watching.